Today I'm talking about the lighting engineering. Uh, I introduced myself. My name is Wong Song. I'm working in Point Tech. Point Tech is one of the AC driver IC company, and I'm working in the lighting industry about 20 years. Today I'm talking about basically conventional lighting and LED technology. Okay, next. Yeah. Humans, they are ancient society. Most of the humans, they are working in uh, living area is outside. So that times the lumens, the uh, illuminance is about 10,000 lux. But in this day, most of the humans they are working in the inside, looks like office. So the lumens needed lux level is just only very low, about 300 lux. 300 lux is means about American areas or European area, but Asian areas they just want about 500 lux. Yes. Uh, how about the lighting or how about the power out? It says that blackout. About 2003 in Europe, that time light scene, landscape is very beautiful, but click the button. Yes, just only one day they have blackout. Power is off, so lighting is gone. That is a dark scene. And most of us persons players very agents quickly. So most of our New Yorkers they are walking to deep reach or they are go to the home by walking and very crowded. And then they they stayed at their stations and just only enjoy the lifetime. So lighting is very important. And then next, uh, basically history of the light source. Uh, most of the light is from about the GE. GE maker incandescent lamps. They are invented about uh, 1879. That times Edison is making uh, incandescent lamp, and then fluorescent lamp is about 1938. That is Dr. Inman. And most of the light source from the GE writings. And in this picture, here Dr. Nakamura. Do you know Dr. Nakamura? He is a Nobel Prizer. He is a blue LED inventor. This is about 10 years ago. I attended in some of the summit meetings. So most of the light source is very important. Looks like LED light source because we are using to conventional light source, same LED. LED is about LED's history is about 60 years, but we are using to about 20 years working in the lighting industry because the issue is performance, right? Okay, this is our natural light energy spectrum. So this is a visible spectrum. Left side is ultraviolet. Right side is infrared. We are using we are using in the lighting industry visible spectrum. But in this day, corona pandemic issue, so we are using ultraviolet UV light source using very capable, and IR using to the some of the medical application. Next. This is a spectrum of the another light source. Yellow line is afternoon sunlight, and the red line is tungsten lamp. Tungsten lamp means that incandescent lamp and halogen lamp. And this is green line is white LED. White LED is basically they are using to blue chip and mixed yellow phosphor. So this is look like a white color. And this is blue line is the mercury vapor lamp. And this just only blue line is scanning code in the supermarket. Next. Okay, color temperature is look like most of our light color is we talked about color temperature. 7,000 color Kelvin is about cool white LED, and 3,000 K is halogen lamps and incandescent lamps. So if we are using two light source and we are choice to light source and then we check the color temperature. Next. Light source classification. Most of all light source they are divided by two kind of light source. One is the solid metal lamp. Solid metal lamp is made by some of the solid. Looks like incandescent lamp. They are inserted in filaments, and tungsten lamp is the same filament they have, and LED is, look like chip. Chip is just some of the metal. But another kind of the lamp is discharge lamp. Discharge lamp is look like this kind of the shape. One is a high pressure discharge lamp. Another is a low pressure discharge lamp. High pressure discharge lamp is mercury vapor or high pressure sodium and metal halide. They are using two street light or the others industrial parts. But low pressure discharge lamp is very famous fluorescent lamp in your office or home and compact fluorescent lamp. Next. Oh, most of all light source they have some of the characteristics. This is fluorescent lamp. The thickness is very thick. So this is a T12 or the uh, slim fluorescent lamp. We talked about the T2, T5, T3, and so on. The performance efficacy is about this kind of the efficacy, and the CRI level is about 60 from 60 to 85. The lifetime is about 10K to uh, from 10K to 20K. Why the lifetime is very different? This is a uh, story. This is a story for fluorescent lamps 3 hours per stop. It means that if you turn on and then the fluorescent lamp's lifetime is three times is decreased. And HI lamp look like this kind of the high pressure metal light and this kind of lamps they are turned on and then the lifetime is 11 hours is decreased. So if you long time turn on the uh, fluorescent lamp or HID lamps, the lamp lifetime is very long, about 20 Ks, or this is 20 Ks, or metal light 12 hours is lifetime. But in our real world, there's turn on and turn off time is needed. One day is about 2 or 3 times, especially fluorescent lamps. We are turn on and turn off, and look like bedroom or the other's room, and then the lifetime is very short. And another incandescent lamp is hours 1K hours. It means that 1,000 hours. And halogen is about twice time because this is a halogen recycling system. So this is Same mechanism, but the lifetime is about two times. LED, uh, first time LED they are saying about 100,000 hours, but in these days we are LED lighting solution, LED lighting fixture. We talk about 30,000 or 50,000. Sometimes some special lighting company they said about 100,000 hours. Next. Oh, this is incandescent lamps uh, function. So could you click this button? Oh, no, 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 no. This YouTube button. More, yeah.
Contrary to popular belief, the original light bulb was not invented by Thomas Edison, but Sir Humphrey Davy in 1809. Creating the first electricity-powered light, the invention was greatly refined 60 years later by Edison, designing a powerful bulb that could burn for up to 40 hours. This was the first incandescent light bulb. To understand it, we first have to recognize light at an atomic level. At its most basic form, light is seen as a series of particles called photons. They are created as excess energy packets when an atom's electrons suddenly gain and lose energy. When an atom is energized, its electrons shift further away from its core. When the energy stops, the electron returns to its natural orbit, releasing built-up energy as a photon. By repeatedly energizing atoms, it's possible to generate a steady stream of light energy. In a light bulb, the energy source needed to energize the atoms is provided via electricity traveling through its base, electricity simply being the movement of free electrons. The key component that made Edison's design so groundbreaking was the filament at its center. Being the most important part of a light bulb, it's the size of the filament that determines the intensity of the light emitted. In an everyday bulb, the filament is about 50 centimeters long, but is coiled down to a smaller size, then coiled again, leaving a 2 to 3 centimeter piece in its place. Tungsten is usually chosen for its extremely high melting point. Electrons burst through the filament, but because it's so tightly coiled, they'll frequently fly off and bump into each other, causing the filament to light up and become extremely hot. All this takes place inside an airtight bulb. If the reaction were to take place in open air, the heat generated would be enough to ignite the surrounding oxygen, destroying the filament. However, in a vacuum, when the filament is heated, the vibrating tungsten atoms occasionally break off. If enough do this, the filament splits and the light bulb is broken. To counter this, the empty bulb is packed full of an inert gas such as argon or krypton. With the gas, any atoms that break off bounce off the gas atoms and rejoin the filament, effectively quadrupling the bulb's life. Although incandescent light bulbs are a staple of modern technology, they've been proven to be very inefficient. An everyday light bulb produces about 20% visible light, with 5% released as light outside our visible spectrum, such as ultraviolet and infrared. The rest is produced as heat, leaving the bulb red hot. To counteract this, the fluorescent light was invented. Using an entirely different process, it's 5 times as efficient at producing light. This will be discussed in a later episode. There are 3 main components to an incandescent lamp: the free-moving electrons traveling through its base, the airtight gas bulb filled with inert gas, and the tightly woven tungsten wire at its center. All working together releases billions of photons, observed as visible light.
Thank you. Yes. Uh, you must understanding incandescent lamp, but uh, very interesting. First, incandescent lamp inventor is not Edison. First man is Levy. Levy is the first inventor for about incandescent lamp, but he is not business. Edison is a businessman, so Edison is a working maker business. So and then incandescent lamp is very famous. Next, this is fluorescent lamp. Fluorescent lamp is high. Fluorescent lamp is discharging lamp. The efficacy is about 80 lumen per watt to from 80 lumen per watt to 100 lumen per watt. Could you YouTube button? Click the button.
But first, arrive at work, unlock the door, turn on the lights. Offices all over Britain use fluorescent lighting because it's cheaper and more efficient in the long run. But how does a tube full of gas light up your life? Fluorescent light bulbs start off as a large lump of hot glass. In this fluid state, the glass can be stretched and blown into a very long tube. Diamond-tipped cutters then trim the long tube down to 2-meter lengths. Occasionally the tubes break, but they're discarded and recycled. The next step is to trim the ends. Flames burning at 700 degrees Celsius create a neat fracture line, and a tiny cutter knocks the uneven ends away. Sharp edges are rounded off, and the tubes are now ready to hold the various elements that will generate light. Fluorescent bulbs are more efficient than ordinary light bulbs, making them cheaper to use and therefore more attractive to businesses. But for that economical light to glow, the inside of the tubes must be coated with phosphor, a chemical that will cause the bulb to fluoresce. Next, the internal workings of the bulb are constructed. Like an ordinary light bulb, the fluorescent tube also contains a filament, which carries an electrical charge. This filament must be put together so it can be fitted inside the phosphor-coated tube. Fluorescent bulbs work by exciting particles of gas with electricity. These particles then emit energy which can be turned into light. Once constructed, the filaments are sealed into the tubes. Now, you may have noticed a glass tube sticking out of the end of each of the larger tubes. This is where the energy-emitting gas will be injected. The gas is made out of mercury, a toxic liquid metal used in a range of everyday objects from batteries to hospital thermometers. Mercury is recycled from these items and collected in a facility like this one. It's a dangerous process and the scientists have to be careful. While handling mercury is a hazardous job that requires a gas mask, the liquid metal can be collected in an ordinary bucket, and a simple trick using water keeps it safe. Mercury vapor is the gas that creates light in the fluorescent tubes, but it's dangerous if inhaled in large quantities. Storing mercury beneath a layer of water stops it vaporizing. Now, if you're worried about the gas in the tubes, don't panic. The amounts used in fluorescent lighting are so small they are not considered very dangerous. The bulbs are now ready to be injected with the mercury vapor. The tubes and mercury are loaded into the filling machine. The mercury is heated, which vaporizes it, and this is injected into the tubes. The heat causes the gas to release energy, and this makes the bulbs glow, even though they're not connected to a power supply. So how do electricity, mercury gas, and a phosphor coating create fluorescent light? We already know that there are filaments inside the gas-filled tube. They send out electrons from one end to the other, which strike the gas particles floating in between. This excites the gas, which in turn emits radiation. But radiation is invisible. And that's where the phosphor coating becomes important. It wasn't to color the tube. The phosphor fluoresces or glows when bombarded with radiation, and this glow is what lights your office. With the insides now phosphor-coated, filament-fitted and gas-filled, All the tubes need are the external caps so they can be fitted into lamp holders. The caps are carefully fed over the filaments, sealed into place, and the job is done. Finally, the bulbs are passed through a tester where any that don't work can be spotted before they're sent out to the stores. Although streetlights were originally powered with gas, the emissions probably wouldn't pass modern standards. But today we can still see, thanks to cleaner, greener gas-powered technology, the fluorescent light.
Okay, basically, fluorescent lamp is a clear lamp, and inside it they have some of the pole moving to the electron, and they are leading to some ultraviolet, and then their inside area is phosphor coated. So phosphor kind of the phosphor they are using to cool light, neutral light, warm light. They can choose, and then there's we can check the first thing is ultraviolet. So we can feel visible light for the phosphor, and that's so light distribution pattern. We know in front of the section stairs we can see the lighting goniometer, and goniometer is they are checking the lighting distribution curve, and then most of all lighting fixture they have a lighting distribution pattern, and this is direct.
Dr. Kim, please, the speaker
저,
isn't.
Dr. Cho, the I can.
Okay.
Yeah.
Yeah. Okay.
Are you hear me?
Yeah.
Yeah. Now I can hear you.
Okay. One more.
One more, please. Yeah. Okay.
Yeah. Okay. Most server writing pictures, they have a own distribution pattern. This is a pattern is a direct type, semi-direct type, indirect. This is a direct type is upward, light is 0 or 10%. Just only out downwards. And indirect pattern is about 90 to 100. And diffusion type is look like this. So we can consider about this kind of pattern, and we can make a design all kind of the lighting fixture. Right? And then we can efficacy comparison. This is incandescent lamp, and this is CFL, compact fluorescent lamp. Same kind of the light source, and we are using the same kind of the reflect lighting inside here. And then first thing, most of the light source they have their own uh, lumen output. This is incandescent lamp, and then this is about 100 watt, and then their lumen output is 1,500 lumen. So they have a own lumen output, but this is efficacy 17 lumen per watt, and this is a lumen CFL's efficacy is about 60 lumen per watt. And then we are calculation by reflector risk, reflector reduction, and then the picture efficacy is just only 10 lumen per watt because reduction is very high. Especially CFR is same reduction. very very high because inside their list. But LED fixture is just only out out areas performance. So lumen output is look like very good. Look like this. So we must design this kind of lighting fixture shape or function, and we must consider about this. Next. And what is the optimal lighting structure? This is a compact lamp, compact fluorescent lamp, and this is a same downlight reflector. And then this is the vertical, same vertical, and this is horizontal. How about the performance? Same vertical is a lower performance, but uh, horizontal type is a very high performance because fluorescent lamp is made by just only industrial areas working light source, and then they are supposed to be flat to the working area. But this is not horizontal, just a vertical to working plane, and then the performance is very low. So if you're using to lighting fixture and the performance is more higher and the good designs lighting uh, and lighting area, and then you must understanding what is the light source's performance and uh, comparison of efficiency characteristic of a light source. Most of all of the incandescent lamp is don't need ballast or SMPS. So just this is a lamp efficacy. But fluorescent lamp and CFL, HID, and LED lighting must be need SMPS or ballast. So the efficacy is anytime exchangeable. So you must selecting good performance SMPS or ballast. Right? And this is Gonia photometer. About 20 years ago, I worked in my first company, and that time I Korea first time this Gonia photometer is making this. Uh, so that times I checked all kinds of lighting fixture, and then so most of the lighting fixture have their own lighting distribution curve. Next page. This is downlight pattern. Most of the same downlight, the same image look like same, but the lighting distribution pattern is look like this. Very, very variant. Okay, next. And this is lighting distribution curve. We said photometric data. What do you think about this kind of lighting fixture? Do you know what kind of lighting fixture, lighting distribution curve? Downlight or street light or industrial light? What kind of light fixture? Do you know? This is just a panel light in the office. This is uh, vertical direction and horizontal direction. Little bit different. Okay, next. This is the same, another photometric data. This is uh, factory lighting or some of the explosion proof lighting fixture in the some of the explosion areas look like this kind of the curve. Okay, next. LED history is about 60 years. I talked about before, but red color is about 50 years ago. They are using to just using to indicator. And Nakamura Suji, they are he making blue LED, and that times most of the light three colors is making blue, yellow, black, and then we can make another color changeover and the color mixing and the color display. And uh, white LED is chromatography design, and there's efficacy is about 120 lumen watts. And then we can using a mobile phone, STD, and PLO, and automobile. In these days, the performance is more higher compared with more all kind of the conventional light source. So we can use all of the lighting feature interchangeable, right? So conventional lighting, we must consider about all of this. What is the light source? If you design the lighting fixture, and then what kind of light source? Incandescent, fluorescent, HID, another compound material, and what kind of driver, and what kind of lighting control, power line, current, circuit design, equipment, and then lighting simulation is all of this is very, very complicated. And the lighting fixture is very different and very heavy and very uh, big size. But LED lighting is just only very, very simple compared with conventional lighting. Next. So conventional lighting, major lighting company, we said GE, Osram, Philips. They are making a lamp or fixture, or they are making a driver. Most of the lighting companies, they are making a assembly, all parts, or some of the they are special design. But in these days, lighting fixture little bit different. Industrial exchange by light source because LED, right? LED structure is look like this. This is a bulb type. We can check the LED chip and bond wire, and this is the lead frame. And this is the power LEDs. Power LED is more hot, more powerful light out. So there's silicone encapsulation and soldering and heat slot and so on. Right? How about the LEDs light output? What kind of the white? How to make a white? This is a RGB mixed white color, and red areas, green areas, and blue areas. They are mixed, and then this is look like natural white. What is your best performance, best mixture? And another another white is just only this kind of the blue chip, and they are covered yellow phosphor, and their spectrum is looks like white color spectrum, and we can uh, we can feel the white color visible light. Button please. So most of the LED manufacturer companies they has own own technology. What is their best white? This is top secret because when I work in so semiconductor, the semiconductor has their own white areas mixed phosphor. So we don't know. Just only project person they have no all mixing light. So if you want yellow, closely yellow white, and then they are mixed here, then do real cool white area they are mixed here, and real white is mixed here. Phosphor is mixed, and then you can make another white. So RGB LED mixed white color and blue LED plus yellow phosphor is mixed, and then they can make all kinds of white colors. And another white color is UV LED plus RGB phosphor. This is more expensive, and but this is a more real natural white, natural color, natural light. So in this day, I know, I think in this day, so semiconductors, some like LED is look like this technology. Next. So this kind of the LED is using to some of the indicating, and this kind of the LED is super box type is using to automobile, and this kind of the top LED is using to uh, interior lighting or exterior lighting. Most of the lighting using to this kind of top LED, and high power LED using to outside or factory lighting, and the other high power LED lighting fixtures. And in these days, most of the small multi-chip size this kind of the COB type. Many a small chip is very crowded in small area, but performance is very good and the lumen output is very high. This jumbo chip applied package is using two uh, headlights for automobile. Correct? So this kind of area using two mobile and this kind of signage, and this is using to automobile and lighting fixture or backlight and so on. This is landscape lighting and another high power LED lighting fixture, right? Okay. Oh, most of the right. This is the same type, incandescent type bulbs. This is LED light source. This is compactive fluorescent lamp. This is incandescent lamp. What is different? The shape is different and the price is different. But bottom areas the big chocolate. And this is light turn on. And then what is how about the chocolate? Please, please button. Okay. And it can be set to left, they are turned on, and that time the chocolate is look like water, and this is some kind of the tree, and this kind of the this chocolate is staying thick because LED is just only right direction. Heat is back direction, but it can distance left and another conventional lighting source. Here, heat area is same direction to the light area. So this is more hot. So chocolate look like this. LED heat area. Okay, click button. LED the heat direction is look like this. But another conventional light is look like same. Okay, and then in these days, most of areas they are using to LED lighting fixture uh, changeable from conventional lighting. But most of LED lighting is some kind of failure or some kind of issues. Most of the issues is from a driver. It means that power supply issues. About 52% issues failure issue is a driver. So you must consider about driver and drivers function and drivers makers and drivers price. Because in these days, very lower cheap drivers in the market, but they are making some issue like in industry. So you must you must check the good SMPS or the ballast or circuit needed. LED issues in maybe very lower. In these days, about I heard about 3 or 2%. Most of the issue is driver, sometimes housing issue. Housing issue is IP grade. So water profit problem. Okay. So in these days, long time ago, we talk about LED lighting mostly consider about the optical heat dissipation, and operating circuit. Operating circuit means that FMPS. We must consider about that. But in this day, this is included all of this. It means that LED light engine. So a big LED or big lighting companies, they are using two light engine. And then lighting fixture companies, they are making some kind of their own lighting design fixture mixed there's light LED engine. Uh, it came conventional lighting industry. For the conventional lighting industry, there are some big companies they are making light source and there's own another company. And another small companies, they have own lighting housing and they are using another big companies like those into and final production. So maybe some of the in the future, some kind of the beans look like this. Next. This is the early writing engine concept. If you want some kind of a downlight and then you are buying this kind of the safe lighting fixture or engine and then you include it in your lighting fixture and this kind of the light engine using to big size factory lighting and this kind of the small size light engine using to some special lighting for uh, high demand output. Okay, this is an application case in California. This is parking lot areas. Conventional lighting is they are using to high pressure sodium, and that there's lumen output. There's light source is 100 watts, but they are exchange 60 lumen 60 watts LED lighting fixture. The performance is more good. But your lighting distribution curve is look like same, and then just just exchange LED lighting from HPS to LED lighting, and then the energy saving is 52%. And 10 minutes delay. It means that uh, parking areas all times working all times there's mass working now. So some drivers parking into the parking lot and he go to his office and then 10 minutes there's dim down. So uh, another scenario is just only 2.5 minutes delay, and then there's energy saving is more higher. So if you consider about the energy saving, and then if you need some of the spatial scenario to control the lighting system, so if you make some of the other areas, common areas, lighting energy saving, and then you must make some of the spatial scenario needed. Okay, Matt. This is the same application case in California. It's a high pressure shooting to LED. The performance is very good, and the energy saving and lighting environment is very good. It's a high pressure sodium and LED induction lamp. LED is more higher, more good, more safer. Okay, right? Oh, this is in my case. 10 years ago, uh, when I worked in the post-school group, and that times I visited to California some of the special supermarket. This is they are using to conventional fluorescent lamp using here. So I suggested to the supermarket owner, if you exchange LED fluorescent lamp, and then your supermarket is more clear and more good. So they first time they don't like this, but anytime about 2 or 3 times I talk about this. If you exchange light source and then yours the stage annual is more higher. So they are exchanged some of the some about half of the section they are exchanged by our LED fluorescent lamp, and then your collecting, yeah. There's a supermarket. It looks like a innovation, very exchangeable, very exchange. So first time their supermarket is chain about the 60 in the market mainly the superior market in California. Most of their customer is Mexican. So Mexican is looks like same Asians feeling. They like cool white and so on. So all of the superior market they are exchange our lighting and our scenario. Oh, next. And the thing, this is there's uh, vegetable and meat areas like sauce. They are using two fluorescent lamp and eucalyptus. Yeah, that area is fluorescent lamps. The car temperature is about 3,000 K. How about your field? Not good. Just already no fresh. How about the lifetime? Very fresh. Lab is good for me. So they're right, right? So if you consider about the lighting, LED lighting, most important factor is first thing is cost because anytime we final selection is cost, but I think we must understanding customer expectation because most of the lighting industry they as customers consider about needed customer expectation. Another is same important factor, but I think customer expectation is more important factor. Thank you. Today's